Hello and welcome to another episode of the Practice Forward podcast. I'm your host, Owen Bush. Today we're joined by Winka Dubbeldam. Hello, Winka. How are you?
Hi. I'm good, Owen. Good to see you.
It's great to see you. Thanks for joining us today. I'm actually so excited to get into all this stuff with you. So Winka is the Dutch-born, New York-based architect behind Archi-Tectonics. Archi-Tectonics is a studio that's celebrated for turning parametric experiments into high-performance buildings. Tribeca's pixelated V33 condos to Guangzhou's Asian Game Eco Park. She is a longtime Miller professor at UPenn, and she is the incoming director and CEO of SciArc. She bridges practice and pedagogy with an ethos she sums up as performance over form. Her book, Strange Objects, New Solids, and Massive Things, chronicles that file-to-factory approach, wiring designers directly to manufacturers. Simply put, Winka designs and envelopes that think and cities that breathe. Exactly the mix of innovation and intentionality we explore here on Practice Forward. Thanks so much for joining us, Winka.
Thank you for the beautiful introduction.
Oh yeah, absolutely. I mean, I feel like I could spend this entire episode just introducing you.
It's really innovative.
But I mean, a lot of really exciting things. I've always been a huge fan and inspired. I'm not an architect. I was inspired a lot though by Buckminster Fuller, and I see Kurt, who works with us at Scantiplan. He's the lead advisor to the Buckminster Fuller Foundation, and he's a deep expert in Fuller. And what Fuller talks about a lot is what they call comprehensive anticipatory design science. And I feel like that's a good way to talk about your work, really. I mean, it's and getting more and more into these kind of things, some of these opportunities you've had in China, really things that I've never seen before. I'm seeing, there's another book that you've written called Synthetic Natures. And so we see a lot of this, I guess, maybe kind of new epoch of design where it's very integrated into nature, and in some ways is reinforcing and sustaining nature in some ways.
Mm-hmm.
So, and then I don't even know where to begin. We also have your new book and this focus on what we call file to factory, which I think kind of, in some ways, kind of reinvents the contract between architects and spaces and all these things, right? Because, I mean, it's for a designer like you, it's sort of, I would imagine, puts a lot of power back into the hands of the architect and designer to be able to realize hyper ambitious projects like you do.
Mm-hmm.
You've always been a big proponent of 3D design, right? And you work primarily, I think you work in Rhino. And so what was the first strange object that you saw that really made you feel like you needed to design in 3D, and what objects are really compelling you like that?
Mm-hmm. I think two things. Maybe one is that I studied initially as a sculptor at the Art Academy in Rotterdam, and So I'm a very 3D thinker by nature. And when I realized I loved sculpture but did not want to be a sculptor, and transitioned to architecture, I kind of kept that 3D mentality going, and never really became a person that designs through plans and sections, but more completely 3D immediately in the computer. And so
Right.
I was also lucky that in Holland, computers were actually earlier. Mid 80s, we had, when I was in school in Holland, we had computers already. Also in the office I worked in Holland. So yeah, I graduated in 1990 in Holland with a tiny 3D wire frame animation, which now would be like just adorable, but then was very impressive.
Yeah.
And then when I moved to New York to do my postgrad at Columbia, I also graduated with computer drawings as one of the only ones, I think, in my class, and got a job at Peter Eisenman, who was already then in the office working in computers, and just started to think 3D there. So yeah, that was, so my coming out of sculpture is probably part of the 3D-ness. And in architecture, the first strange object I saw, which still inspires me probably the most, is a building by Hans Scharoun in Berlin. It's called the Philharmonie, and it's a strange tent-like building. It looks like a cross between a nomadic tent and a concert hall. It's concert hall. A very beautiful building, clad in some sort of brass like shingles. And he calls it himself his ugliest building. And I thought it was the most intriguing thing I'd ever seen. And I started to understand that I wasn't so interested in standard beauty or whatever people call style of things. I was much more interested in how did this shape come into being. And it's very much what you just said about Buckminster Fuller. You know, when you look at the intelligence of a thing, or you understand it as a provocative scientific research element, then the shape comes out of that, and often becomes maybe a shape you haven't seen before and doesn't have a standard beauty. Yeah. So I have always been very attracted by that. I drove an AMC Pacer for years, America's first compact car. Mostly either people loved it or they hated it, but I thought it was the best car ever, and thought it was intriguing that the back of my car looked like the front of a helicopter, which was amazing. So yeah, it's that curved car that is also in Wayne's World. And and it's also in Man in Black. I think Man in Black 2 has a black Pacer in it. Yeah. So anyway, so I've always been intrigued by strange shapes and weird coincidences.
Yeah.
You know, and I think that gives building some sort of level of identity and sort of character that we as humans can relate to.
Yeah. I mean, you're from Rotterdam, or you went to school there?
I went to the Art Academy and the architecture school in Rotterdam. Yeah.
Yeah. Yeah. Well, I mean, that's just an amazing, if you talk about just the appearance of reality around you. I mean, Rotterdam is just an exceptional architectural city because it was just completely leveled in the war. So everything is modernism and postmodernism there.
Exactly.
And I mean, when I was in Rotterdam, it's always about what those cube houses.
That was my school.
What's
so
that?
My architecture school was in the cube houses. Yeah, in the bridge.
Oh, really?
Yeah.
Yeah. So I mean, I mean, when I first went to Germany and the Netherlands, I was like, okay, so the Germans really love squares. They're really into squares. The squares have to be perfect. And then I went to the Netherlands. I was like, oh, okay, they seem to like diamonds here. You know,
yeah.
Everything seems to be at that Dutch angle, as it were.
Yeah, and I like quasi crystals.
Right. Yeah. Exactly.
The misformed version of a diamond. Yeah.
Yeah, it's sort of a diamond. I mean, it's yeah. So, your studio mantra is performance over form. Um, I would imagine you're also very attracted to all kinds of elaborate forms. So how do you use give me some examples of how this comes up and how you work with your team?
Well, yeah, it's basically a little bit what I said earlier is we study kind of, if we get a program, like for example, the Asian Games is probably the most recent example and easiest for people to find. We were asked to do that park you just mentioned, 116 acres. Was bifurcated by a road and by a river. It had to have 2 stadiums, and because the Chinese government asked us to make a sponge city, which means it absorbs rainwater for the city, it filters, it also retains the water. You know, all the flooding we have right now is because we don't have enough sponge cityness in the city.
Yeah, yeah.
And they also asked us to make the park 85% park. So that led to 2 kinds of buildings. One is an earth building, which is not a building with a green roof, but like nature with a building under it. So different proportion, let's say. And the other buildings we proposed to the client, since they were so carbon neutral thinking, we thought, well, the only not carbon neutral thing is to make 2 ginormous stadiums of 35,000 square meters, which is about 350,000 square feet, and make these buildings like something you either tear down or become a white elephant. So we proposed to make these hybrids, a stadium during the Olympics and a concert hall afterwards. And the client really loved that idea. Funny enough, we got some more budget to build the buildings because now they're permanent. So we froze the carbon footprint, but it also led to me thinking when we were designing it and we made the perfect stadium, that stadiums are one-liners. And I thought, people are never going to understand this building as a concert hall. And if it is a true hybrid, it should probably have a new taxonomy or typology. We call it typology in architecture. It's taxonomy in nature. And I like to, because nature has a much more dynamic version of typology, which is taxonomy. I like to call it taxonomy. But anyway, so we made a building that has the intersection of the inner and outer bowl, which starts to transform the building in a much more complex kind of form. But also what is beautiful is that inside, therefore, movements are much more fluid. It slips very beautifully in and out of itself, so into nature or out on a suspended balcony. So it gets these rings of movement because of these intersections. And it facilitates the transformation of stadium into concert hall, because now we could build in the future bar, the champagne bar for the theater or concert hall. And so these things were facilitated by it. But the building itself had this very strange characteristic where glass facades were intersecting with brass shingles, and it became a little alien, let's say, which was really lovingly adopted by the neighbors, who all study it and photograph it and make documentaries about it and take selfies in front of it. So it's the favorite spot to take selfies in that city. Which is
must be an incredible place. What an amazing gift for the folks who live there.
Yeah, they love it. Yeah,
it's pretty unusual to have access to something like that in China. I think for most folks.
Yeah, and it got 116-acre beautiful park with wetlands and rivers and 8 bridges and bicycle and running paths that are all porous pavements. So yeah, it's a very lovely area where people are allowed to camp and garden and kayak and do sports. And there's a playground we initiated because we thought the park is really for the people, forget the Olympics. So yeah, we did a lot of
just to describe so you can, our audience can visualize this. It's actually built into, there's actually like a forested area above the roof, so it's really built into the landscape.
Yeah, that's the earth buildings. Yeah.
And but all of the buildings really feel like they're, somehow, they're very organic forms, and they really feel like they're a part of the landscape.
Yeah.
And then obviously using a lot of extremely advanced sustainability technology here. Are these buildings sequestering carbon in some way, or are they doing?
Yeah, well, what is beautiful, of course, about making a building that is part of nature is that the park itself creates huge amounts of oxygen and absorbs
Right.
amounts of.
Yeah.
It's really a carbon sink itself.
Yeah.
The buildings need actually no insulation, so we don't use any toxic insulation materials, because the earth itself is so insulating that it doesn't need that. And because we worked with Thornton Tomasetti, structural engineers, but also their environmental group, we saved, I think, 20 tons of steel overall by making the structures extremely light and almost flying. So the buildings are heavy on the bottom, but super light on the top. So it's kind of a mix of, like, where you need heavy, you use heavy, but then where you need light, we use it almost like cloud-like buildings for the stadiums. So those are really beautiful, airy buildings that are like close. Actually, the field hockey stadium has this huge wing of 125 meter span, which is about 375 feet, I think. And that is one free span. So it shades the field, the viewers, and the glass lobby. But it looks also like a really beautiful low element in the landscape. One thing we did, which was really helpful, was like we used something called the Zero Earth strategy, which means that the earth you excavate, you keep on site. And so for example, parking garages would then get earth on top, and we have 20-meter high hills just from excavating the valley or the wetlands or any of those things. But keeping the earth on site is also biologically really important for the biome. So anyway, long story short, very exciting project. Yeah.
Performance over form.
Yeah.
Which is a lot to say, because there's quite a lot of form, so there must be quite a lot of performance.
Hopefully, I love that. Yeah. I might coach you on that.
Let's talk about your this term you've coined, FTF. So this is about file to factory, which would probably be the holy grail for all these different types of parametric designers. And you think about like an architect like Frank Gehry, or any of these architects who are doing very whimsical forms that haven't been seen before. But in general, I think so obviously this is something that's really going to empower 3D thinkers like yourself. It also, I think, is maybe you're also an educator, and I think we spend a lot of time talking to professors who are thinking about the world that their students are going to be coming into, and the way that they should be thinking in terms of what is the next era of architecture going to be bringing. So tell us a bit about. I think File the Factory has a huge part to play in this.
Yeah.
So tell me about this pipeline and how it really disrupts things in the way we think about construction.
Yeah, as I was fascinated by three-dimensional design, we designed a building as early as 98, 99, I think. And I wanted to make a folded facade. And first I was thinking, I'll just use caulking, on the folds. But then my engineer kindly explained that forces go down and the caulk wasn't strong enough. So then I thought maybe I should actually bend the glass, and called one of my friends who's an expert in glass, Jamie Carpenter. And he said, speak to Boeing. in LA or this glass company called Creekers in Barcelona. So I talked to both of them. One of them got the job, and we actually physically folded the glass. Now, in order to get that done, I also wanted the mullions to be in the same direction because you don't want to make straight mullions and then crash glass or something. So we realized that early, like, so let's say 98, that our drawings in the computer, 3D drawings, were basically it. That we did not want to send 2D drawings. It would never be clear to the, the extrusion of the mullions in one country and the glass in another. So we sent around a 3D model of the facade with XYZ points in order to make sure that the glass and the mullions would be exactly the same, which worked, which was the biggest. So that is kind of maybe the first attempt on a parametric facade or a parametric model. Very manually thought of, but in essence, that's still what parametric is. So, and that file went to the factory, both in the extrusion of the aluminum and the glass. And then they met in Brooklyn, where the facade was unitized and put on the building. So it was a crazy adventure. It was super scary, but it worked as a dream. And we jokingly always said to the contractor, like, don't, it's not VIF, verify in field, which we usually put on drawings. It's VIC, verify in computer. Because whatever the size is in the computer is what you need to build on site, because that facade is already being built. So this is what you talked about earlier. It gets a little tricky because what you do is you work straight with manufacturers to get this facade done. But the contractor does not necessarily like that, because now you are mixing in their business. You already know the quote, so they can't upcharge it. It gets a little bit hairy sometimes, but it does guarantee the quality, and it also means that you don't get a building that's extremely expensive. That turned out to be a very affordable building, where I was extremely proud of the fact that we kept it that affordable. And that's also because we worked very, it was a very funny story, because initially I thought, oh, you just call a curtain wall company, you say, well, this is 90% standard and 10% deviation. And they immediately made it 300% more expensive. So that was not going to happen for my clients, which was like one of his first developments. And so then we started thinking, okay, so let's not use a standard system, let's make a custom system. And then it became super simple. So we made the verticals in steel, the rest extrusions in Hong Kong, and the glass in Barcelona, and the whole thing came together. And it is a very, very beautiful facade. I mean, it's still looking really pretty. I walked by the other day and I was like, this is now almost, what is it? So 2004 it was completed. So it's like 20 years old now.
Wow. Yeah. Just for our audience, which building is this again? This
is 497 Greenwich. It's on Spring and Greenwich Street so west of Soho in New York City on Manhattan.
Yeah. And so I'm actually looking at this, and it's interesting that, you did this 20 years ago, but, I've actually been talking to a lot of folks, because we talk about technology on this show. I've been talking to them a lot about, how they're seeing like the way, AI modeling tools and things like that might help them. And they're basically talking about, what they want to do is model the entire regulatory environment first, and then look at all those constraints and then think about the modeling. But I'm seeing that, but at the same time, when I look at this breakdown here on your website, you're showing that what you guys did is you modeled the setback code, you modeled the sky exposure plan, right? And then from that, then you're bringing in a lot of this kind of creative sort of parametric design into that, right?
Yeah. Essentially, because this was the thing, I was from Europe. So for me, things can be really interesting and surprising. So I always thought buildings had setbacks, like the wedding cake scenario. You go over and up and over and up steps. And then I realized that plane, the zoning, is actually an angle. So I thought, how beautiful. I can basically use the straight facade and the angled facade, use inflection. So angle goes to straight, straight goes to through angled, and make the whole facade kind of a waterfall coming down. And that was super interesting to me because it became instead of two different things, one thing that is taking the parameters of both, let's say.
Mm.
And still follows perfectly well the zoning regulations. But yeah, it was kind of fun.
Yeah. And it just looks like a cascading waterfall of glass.
Yeah,
It
yeah,
almost looks a little bit like there's an earthquake happening or something, but I'm sure it's very stable.
it's very been there for 20
Oh,
years. We had actually a few earthquakes, and it's still standing. So
good, good. So yeah, this is amazing building. Everyone should have a look at this one. I'm looking forward to seeing it in person. So it's your firm really is doing such a wide variety of things. I can tell that you're quite a generalist in the way you think about and approach projects. So you're doing a lot of projects in New York City, as well as these really epic projects in China. And so are you doing any of these smaller projects now, or are you mostly focusing on these more large scale projects?
both. We
Uh-huh.
always we did a dental office and treatment area in New York, and I love doing that because as long as the clients are interesting to me, every scale is fine. But we're
Yeah.
doing ginormous master plans in Albania at the same time. So for us, I actually like that kind of working both in a big scale and small scale, because the bigger scale projects you can redline facade drawings forever,
Yeah.
and it takes a few years, but in the meantime you can finish a beautiful workspace for a dental surgeon, or a duplex apartment for a friend, or I just finished a house for friends in London.
Uh-huh.
And to me, that makes it exciting because you have projects finishing in different speeds,
Yeah.
which keeps it exciting because for a while I had only very large projects, and
Yeah.
it's very mind numbing to have to constantly redline and endless meeting reports and making agendas. And it's at some point you feel like, and a little project would actually be nice. So I
Yeah.
went back to accepting, if I like the people, I went back to accepting smaller projects. And sometimes a small project, it's not that small. We did a townhouse of 6 stories for a fashion designer. And then she loved working with us. So then we did 3 stores in Shanghai, Paris, and London, which were enormous stores, like 3 stories on Rue Saint-Honoré, my favorite project because it made me go to Paris all the time.
Hmm.
And then we did her house in the country. So I mean, sometimes a small project becomes a repeat client that you work with over many, many years and
Right.
really develop a friendship with. And yeah, it's a beautiful relationship that way, because it's also built on trust. No, they really, you deal with a very personal space. It's a lot of money to build things, so yeah, they really need to trust you.
Yeah. So, and it seems like you have a pretty small firm, right? It's you
Yep.
keeping it pretty lean.
Yeah,
So,
I don't want a big
uh,
office. I like design research more than producing a million buildings all over the world. I like a few precise buildings in my life, but not.
yeah, certainly, yeah.
Yeah.
Well, it's incredible how much you're able to accomplish with such a small team.
Yeah, but don't
Um,
forget, like we had 60 people in China, I think, with a full
uh-huh,
BIM office, a local architects, lighting
uh-huh.
designers, garden plant designers, landscape architects, engineers, MEP engineers. I mean, the meetings were, we had to run these meetings, but they were like humongous. There were like 60 people every time on the table,
Yeah.
and all with questions. And so yeah, we orchestrate a lot, but yeah, I think a small team of highly educated people can do a lot of work. We don't have much hierarchy in the office. That's the other thing. We have an office of 12, 15 people, but we're all, architects. There's one administrative person suffering with all the boring architects.
Yeah.
But yeah. And then, we have a lot of people working with us for many, many years. I decided early on that I would take all the bookkeeper, accountants, lawyers, and all that stuff as experts outside of the office. So we have a lot more people, but they're not in the office.
Right.
So because I like to have these on a very, the best people for the rest of my life, kind of. So I chose experts in accounting, experts in PR, and so they're working with us since God knows how long, but they're not here in the office.
Absolutely, yeah. That's my approach too.
Yeah.
So now, so you have a new position coming up with SciArc, and also I would imagine you spent a fair amount of your time working on as an educator, right? With UPenn currently, right? So and you've also taught all over the place, right? Are you going to be really focusing on file to factory? Is that a big emphasis on what you'd be doing at SciArc?
Well, I think the reason why they managed to pluck me away from New York is because they were very interested in having a practitioner running the school.
Right.
So, so they accept the fact that I have a practice, which is very generous of them. And I think what is really important, what is an important shift in architecture and the office, the practice, is that digital design has made this kind of very fluid transition from architectural design to, well, first research, then design, to file to factory, but also to immediately working with engineers. So we can send our very early 3D models to a structural engineer and make sure that that is integrated. So it's no longer what used to be, oh, you do a design and then you send it to the engineer. In this case, we do literally a sketch, and we already work with the engineers on it to optimize everything in the same kind of fluid geometries. So that it also is money, that's why we save so much steel. That's why we can often accelerate the construction time. I think in the Asian Games, we managed to accelerate it by 20%, which is a lot. Yeah, so that is for I think students really important, because it means that I think as architects, you mentioned it earlier, we get a lot of power back because of that, because you orchestrate this 3D model that really becomes the basis of everything. It becomes the basis of a BIM model. It becomes the basis of all the PR renderings, but also the basis for the structural and mechanical engineers. So I think in that way, I think it's important to educate students in a sort of design research level. And what I did mostly as chair at Penn was to kind of hire a standing faculty that was very focused on design and research, or structures and research, or even, advanced architectural theories. So we focused on, everyone we hired had the word design in it and the word research in it, even if they were in structures or in history theory. So to really kind of deepen the way we work and to make a much more rigorous process. And that has been phenomenal. I mean, they were a group of absolutely fantastic colleagues that I still very, very much appreciate and love working with. So that was beautiful to do that in 10 years and to really get that built a huge robotics lab where we work a lot in 3D printing with biomatter, which means facades start to actually produce oxygen and absorb carbon, which is super important because construction and households alone is 40% of the carbon footprint. So if we can change that as architects, we have a lot of agency. So that's the...
Okay, but along those lines, I would, okay, let me make a counter argument here because, as I talk to more, I mean, my stepdaughter just did the summer, she's 15, she just did the summer architecture program at Rensselaer. I've spoken to a lot of other professors on this podcast who are teaching undergraduates, and they're always saying, first of all, it's very easy for this generation to think about a 3D model on a 2D screen. And that's kind of how they orient to design. And they can do it easily. They can start over, they can delete it, they can make another one. They're very good at that. And they orient, they tend to have that bias, right? And that what I was saying is it seems as if there tends to be a bias towards doing new construction coming out of schools because it's so much easier to just design something in a vacuum. Whereas it seems like most architects spend, 80% of their time dealing with some form of existing building, whether it's adaptive reuse or it's some other form of adaptation. And yet I feel like students don't really have that experience in school. I feel like most of them would dream of being an architect like yourself, where you're making these completely fantastical.
Hey, 47 is adaptive reuse. It's wrapped around, that whole building is wrapped around an existing 6-story warehouse. So
of course,
very adaptive reuse.
Yes, no, I'm not saying that you don't do adaptive reuse, but and certainly, like, a lot of the new construction that you've done is far more sustainable than anything that's ever been built before. So nothing wrong with that. But
but I take your point on the students. Like at Penn, we do have a housing studio where we specifically work with adaptive reuse for that reason. And we also get city experts in, and neighborhood people and community leaders, and we work on libraries in the neighborhood. Philly has very poor neighborhoods. So we work with the community leaders and the people there to work on neighborhood libraries, small branches, a lot of adaptive reuse. We really work within the neighborhoods and with the people, because we feel like students need to get that experience. You're totally right. You cannot work in a vacuum. You need to, and also don't forget what the beauty of American education is, these long summers that people have no school and they can do internships. So basically the internships are an integral part of the education, and that helps also like assess what they've learned, and they can test it in the summer and come back with a more solid opinion. And I mean, I think graduate education is really teaching grown-ups, right? It's a dialogue. We don't tell the students what to do. We have a dialogue with them. Especially in the last 10 years, it's been a very difficult period with all kinds of things going on, as you know. And the way we worked around it is just keep talking to the students and ask their opinion and say, how do you want to deal with this? Like, what do you think? And I think, that's the beauty of graduate school. Undergrad, you really have to teach them from scratch. But in the graduate program or postgraduate or PhD, you have full grown-ups that, work with you. So they have opinions and they ask for stuff, which I love. I think that's the great thing.
Well, so I mean, how do you How has your approach to educating changed, let's say, over the last 5 years with new technologies that are coming out, and also just having new generations that are, now we're going to have a whole generation that grew up with AI,
Yeah.
And how, how do you think, educators need to change, if at all, how they approach the practice?
Yeah. Well, if I'm the generation that still saw manual going into digital in the 90s, and honestly, it didn't change much, right? We all thought, oh, it was I remember discussions, the end of the author. It was like everything was going to be done by the computer. We were no longer necessary. And I kind of think it's kind of cute and adorable that people are like, AI, everything is going to be taken over by the computer. It never happened, right? The computers only work because we turn them on, we put parameters in, we test the parameters in some software, and then we choose and edit what is the outcome, and then we recombine it and change it and work with it. It's just another tool. And I love it. I think AI is fantastic. This morning I sent a small PR thing for my clients. We're doing a flood-proof, hurricane-proof, fire-proof house that is custom built but prefabricated, very lightweight concrete. Only 3 inches walls in concrete. So I gave him a short slogan of like, high design meets time responsibility and cost dependability and time responsibility, whatever, something, I forget it now. But anyway, what was great is he put it in Chat GPT and came back to me with this very flowery, beautiful, poetic text. And I was like, yeah, that's what I meant, but it sounds better. And that's the great thing of AI. And, you give it the meaning, you give it the parameters, and it comes out in a way that sounds like Shakespeare wrote it. And that is that is fantastic. It's a really fun tool to play with.
Yeah, well, it definitely, I think, I think, obviously you have a mind that jumps around to a lot of different things, as do I. And it's great to be able to learn about things so quickly now, just really take a deep dive into something. I mean, even if half of it is hallucinated, you still learn more than you would have earlier.
Yeah, exactly. Yeah.
So now let's talk about this Inkscape project. So I saw this thing in the New York Times and it really blew me away. A photo of this dome that you designed. It's a dome that's designed for meditation. Completely blew me away how beautiful the design was. Is there any kind of science or applicable information, metrics, etc., that you guys use to develop this? Is there something behind how this may help us to meditate better, or
Yeah, I mean, I meditate since high school, I think. Yeah, I've been meditating for many, many years, half my life. I was very lucky that one of my girlfriends had a grandmother who was in yoga and meditation. So from like the beginning of the Art Academy, let's say, we were doing yoga and meditation. And a friend of mine who was in the fashion business went into a silent retreat for 3 whole weeks, which is a long time, and came back completely enlightened. And first tried to convince me to do the retreat, which, is only possible if you take 3 weeks vacation, which I don't. So I was like, well, you just tell me about it and then I'll vicariously enjoy that. So then the next lunch we had was him saying, I think I should stop fashion and be more spiritual in the rest of my life. And what do you think about, do you know some person who could design a meditation dome, a meditation space? And I was like, yeah, sure, I can. And love to do that with you. I like startups. So we kind of became partners in that. And what is really interesting, of course, in meditation is that it's much easier when you're at the ocean or when you're in a desert, right? Like you have a horizon line and you focus on that, and the silence and the vast space around you really helps calm your mind. So when I was designing it, I thought we should make sort of a very large ellipse that has a horizon line where we also put a light line. And then in order to make, because it was a space supposed to be for 45 people, in order to make that span, we looked at just structural principles of a radiating grid shell, which is basically a grid shell, and because of its radiating lines, it gets much stronger and can span much further. I am a strong proponent of bamboo, so we made the whole dome out of bamboo, made the seats out of bamboo, made the floor out of bamboo, and then covered the grid shell with linen to make it look really simple and easy inside. But what is kind of a fun backstory of that dome is that it's probably technologically the most extreme, because the client was an extremely perfectionist person. So the sound had to come like it was omniversal, right? So there were teeny weeny speakers everywhere. The lighting, we wanted to have a top ring and a bottom ring, and then when you come in, it's equally lit, and then the rings separate out so that you get this horizon. It was special music, and it was a special sound system. The air had aromatherapy, tiny points again along the ring that came up, so there would never be a breeze. It was perfectly even. It was very fun. Yeah, acoustically, we even hired Ove Arab, which is like the best engineer in the world, to do the acoustics, because we made it too perfect, which meant, which is kind of interesting, it meant you heard everything.
Right.
So Ove Arab came in and messed it up a bit. And that was a cute lesson, it was a great lesson in acoustics. And they added white sound that you don't hear at all. But it makes it perfectly quiet. But otherwise, you were in the space with 45 people. You hear every breath. You hear every even flap of an eyelash. It was so quiet. But yeah, that was very, very interesting. So yeah, and that became a highly popular space. Really great. I did a lot of it. Also, I was there a lot. I took all my clients. We took the office. We had seating patterns here on the floor to test how close you could be without being comfortable. Even the dog was involved.
Yeah.
So yeah, it became a very haptic kind of tactile study in proximity and comfort and relaxation. It was really interesting. And I have to say, it's probably a case study for how we later developed the stadium.
Oh, interesting.
Which is very similar in the roof. Yeah.
Yeah. Well, what else do you learn from that project that you think you would integrate in the future?
Well, I think a lot of things, like the whole thing was we wanted it because you cannot be sustainable if you transport things too far. So we, instead of a drawing set, which is a normal construction set, we made kind of a manual, like how you would put an IKEA cabinet together.
Right.
So we made a manual so you could give it to local prefabricators and make it where you need the thing itself. So that was really interesting. We had a packing model of how you could pack it in a container if you did have to ship it. We had all kinds of interesting little experiments to sort of see what would be the best way or how could you. But I think the manual and fabricating it locally was probably the most efficient. But yeah,
Right.
yeah.
Yeah. Huh. So, so Strange Objects, New Solids, and Massive Things. This came out last year. Is that right?
22. Yeah.
Oh, sorry, 22. Okay,
Yeah.
but that's pretty recent.
Yeah.
So I'd say it's pretty current, and it's so once again we're talking about architects collaborate directly with manufacturers, and so give me one story from that book that really captures this designer meets factory floor moment.
Well, the book, I'll show you. What I like about it is that the publisher, it's this book. And it has holes in it.
Oh, wow. That's cool.
You see that?
Oh, yeah.
And then it has to be clear, everything on the, on the title. So it feels like a stack of papers, you can see, with holes in it. And the graphic designer had listened to the concept and said, well, this is really not a monograph, it's a manual. How you innovate in architecture by working with manufacturers, more or less like industrial designers do. And so he had looked at the manuals of tractors in the 30s, and they always had, these manuals had holes in it, so you could stick it in the binder. And then you could get a new set, and you could update it next year. So he wanted this to be a manual, and so hence we got the holes in it. And it's really like it's on your desk, it's like a stack of papers, you know, it's like really casual and really interesting. But and then his idea was that the basically everything aligns at the top as a washing line of experiments and innovation. And all these have codes, and then there is gossip, a list of gossip that I made in the back on every stage, because what was kind of beautiful about this book is that it was finished. I finished it during COVID, and it gave me time to go back to all the manufacturers. And for example, with the glass, folded glass, I could go back and say, why did it take 4 months before you actually made the first piece of glass? And, you know, I got the backstory of what had actually happened and the experiments they had to do, and that they were on the brink of telling me it wasn't possible when they made finally the right one. And so I never knew that this was on the brink of being canceled until they made because the glass kept breaking. And because, you know, when you fold glass, what it wanted to do, it wanted to curve and then have a little counter turn and then go flat. But they didn't want that. They wanted the perfect curve and then from curve to flat. And it kept popping because they were either doing the heating up too fast or the cooling down too quickly or too hot or too cold. And it took a lot of calibration before they finally could make the perfect slump glass. And it was an amazing story because I was like, oh my God, this is insane. And I knew it was something going on because we didn't hear from them. They didn't pick up the phone. That was mortifying. And and that was a really fun story. So that's in the book, for example. So I talked to all the people. When that happened, when I got that story, then I started calling all the other people and saying, so how did this go? And what was the backstory? And was it easy? Was it difficult? And things like that. So it was fun to make that book in COVID because it gave me the time.
Oh, that's great. Wow.
Do the research.
Yeah, interesting. Yeah, no, it's good. I mean, I get a lot of that same kind of thing by doing this podcast and being able to actually talk to architects.
Yeah.
So it's a manual. Are you thinking about adding some new chapters in the future?
Now we're working on a new book that is called Monsters and Mutants.
Oh yeah?
Yes, and it talks about how plant intelligence can be a clue on how to work on global warming.
Oh, interesting.
Yeah, and that's that book, and that comes out the end of this year with Park Books in Switzerland.
Wow.
Yeah.
Well, that sounds very exciting. And as you mentioned earlier, you are working with some new materials, printing biomaterials, and so obviously there's a lot of research happening there.
Yeah.
That kind of biomimicry and materials, and that's a whole other area we didn't have a moment to even discuss, really. So much going on in your world, Winka. We'll have to have you back and get more into all of these things. Thank you so much for your time today. Winka's firm is Archi-Tectonics. It's ARCHI-tectonics.com. You can see her work there, and she's going to be moving on to SciArc, which is SCIARC.edu. Does that mean you're going to be moving to the West Coast?
Half.
Oh, yeah? Okay.
Well,
I hope to see you in New York next time I'm down there. It'd be great to catch up with you.
Absolutely. Yeah. Let me know.
Okay, very good. So anyway, once again, it's a Practice Forward podcast. We're sponsored by Scantaplan. It's scantaplan.io. And thanks so much, Winka. We'll see you again soon.
Thank you, Owen.
Have a good day. Cheers.
You too. Bye-bye.